Hello and welcome to day 13 of our course. Today we are going to explore two powerful design patterns, the prototype pattern and the object pool pattern. Both of these patterns play a crucial role in improving the efficiency of object creation and resource management in your system designs. Let's dive right into the understanding what these patterns are, when to use them, and how they can make your designs more efficient. By the end of this session, you should be able to understand both the prototype and object pool patterns, know when to apply them, and be familiar with their real-world use cases. We will also dive into some practical coding examples so you will get hands-on experience with these patterns. So let's start by looking at the core goals of today's lessons. Let's begin with the prototype pattern. At its core, the pattern is all about cloning objects rather than creating new instances from scratch. Picture this, you have an object with a certain state and you need many similar objects in your system. Instead of recreating the object and setting all the values again, you simply clone it. This pattern is ideal when object creation is costly in terms of resources or time, such as when constructing objects with complex states. In this pattern, we define a prototype interface, usually with a clone method. The concrete classes implementing this interface will provide their specific implementation of the clone operation, allowing the system to quickly generate similar objects. So why and when would you use the prototype pattern? This pattern is particularly useful when you need to create a large number of similar objects and the process of creating each object from scratch is expensive or complex. For example, in a game engine, you might have various types of enemies, all having similar attributes like health, speed, and strength, but each instance may vary slightly in these attributes. Instead of recreating each enemy from scratch, you can clone an existing one and adjust only the differences. The prototype pattern saves time, avoids repetitive initialization, and minimizes the overhead of creating identical objects over and over again. But remember, implementing deep copying for objects with complex states can sometimes add complexity. So it's important to evaluate whether this pattern is the right choice based on your system needs. Let's look at a simple code example for the prototype pattern. Imagine we have a shape class that is the base class for different shapes like circle and rectangle. Each shape has a clone method and different shapes provide their own implementation of how they should be cloned. In this example, the circle class overrides the clone method to return a new instance of a circle with the same properties. This way, instead of creating a new circle object from scratch every time, we can simply clone an existing one and modify the necessary properties such as the radius. This approach ensures that we save time and resources, especially when creating multiple instances of similar objects. It's important to understand the difference between deep copy and shallow copy when working with a prototype pattern. A shallow copy creates a new object but does not copy the objects referenced inside the original object. Instead, the references to these nested objects are copied, meaning changes to the nested objects can affect the original object. On the other hand, a deep copy creates a new object and also recursively copies all the objects inside it, making the new object completely independent of the original object. This approach ensures that no unintended changes can occur between the original and the cloned objects. While deep copying can be more costly, it ensures complete independence of the objects. Now let's move on to the object pool pattern. This pattern is focused on resource management. The core idea is to maintain a pool of reusable objects instead of creating new ones each time they are needed. Imagine working with expensive resources like database connections or network threads. Creating these objects repeatedly can lead to performance bottlenecks and increased memory usage. The object pool pattern solves this by keeping a pool of objects that can be reused when needed. If an object is available in the pool, it's returned for use. Otherwise, a new object is created and added to the pool. Once the object is done being used, it's returned to the pool for future reuse. This way, expensive operations are avoided and resource management is much more efficient. So, when is the object pool pattern most effective? This pattern is perfect for scenarios where object creation is expensive, such as in cases where you are dealing with database connections, threads, network connections, or large objects that require significant initialization. Rather than repeatedly creating and destroying objects, we can reuse them, which reduces overhead and improves performance. However, the object pool pattern does introduce the need for proper management of the pool. If objects are not returned correctly or they become stale, it could lead to memory leaks or degrade performance. It's crucial to ensure that the objects in the pool are properly reset and ready for reuse. Here's a code example that demonstrates the object pool pattern. In this case, we have a connection class and a connection pool class that manages a pool of available connections. Whenever we need a connection, we simply request it from the pool. If a connection is available, we use it. Otherwise, a new connection is created and added to the pool. When we are done with the connection, it's returned to the pool for reuse. This pattern minimizes the overhead of repeatedly creating and destroying connections, making the system more efficient. When working with both the prototype and object pool patterns, there are some important best practices and pitfalls to be aware of. For the prototype pattern, always ensure that your cloning method handles all the fields correctly. If your object contains mutable fields, you should implement a deep copy to avoid unintended changes to the original object. For the object pool pattern, it's essential to reset the state of objects before returning them to the pool. This prevents issues where objects could retain old states and cause bugs or inconsistent behavior. Additionally, managing concurrency is critical. If multiple threads are accessing the pool, make sure access is thread safe. Let's look at some real-world scenarios where these patterns are used. For the prototype pattern, game development is a classic example. Imagine a strategy game with different units like soldiers, tanks, and airplanes. Each unit has similar properties, but their individual attributes differ slightly. Instead of creating new objects from scratch for each unit, we can clone an existing one and modify the specific attributes. This saves a lot of processing time and memory. For the object pool pattern, consider a web server managing database connections. Instead of opening a new database connection for each request, the server can pull from a of pre-established connections, thus significantly reducing the overhead of connection establishment. Another example could be thread pools in multi-threaded applications where threads are reused rather than constantly created and destroyed. Now let's put your learning to the test with a hands-on practice exercise. For the prototype pattern, your task is to implement a prototype manager that can manage a collection of prototype objects, allow for cloning them, and modify their properties when necessary. For the object pool pattern, try building a simple string buffer pool. This pool will manage reusable string buffers that can be reused across different operations. This exercise will give you a concrete understanding of how both patterns work in practice. For your homework, I would like you to design a document editor where both the prototype and object pool patterns are used efficiently. The editor should allow cloning of document pages, and it should manage reusable objects like spell checkers or text buffers using the object pool. Also think about the trade-offs involved with deep copy versus shallow copy, and consider the risk of having slayed objects in the pool. In summary, today we explored two critical design patterns: the prototype pattern, which helps us clone objects instead of creating them from scratch, and the object pool pattern, which allows us to reuse expensive objects rather than recreating them. Both patterns help optimize resource usage and improve system performance. Tomorrow we'll move on to explore the adapter and bridge patterns, two more patterns that will help us design flexible and maintainable systems. Stay tuned and thank you for your attention today.